Hello, everyone, and welcome back to Climate Conversations. I'm your host, Kathy Yang, and today I'm here with Dr. Fries. Dr. Fries is the Cochrane Family Professor in Earth and Environmental Sciences and also the director of the Center for Public Policy Research at Tulane University. Additionally, he helps to lead the mangrove lab at Tulane and has previously taught at the National University of Singapore. Dr. Fries specializes in research with coastal wetlands and mangroves, blue carbon, and climate change. Would you like to add anything to your bio?
No, that was really nice. Thank you. I appreciate it. Thank you. And thanks for the invitation to chat
And
with you.
thanks for joining me today. So if you could give like a quick summary or explanation about what blue carbon is, or like, because I know it can be a bit of a more niche word, if you could
Sure.
talk about that.
Yeah. Blue carbon is a very emerging theme, but yeah, it's not something that everybody will be familiar with. But really, it refers to the ability of a select group of coastal ecosystems, particularly mangroves, salt marshes, and seagrasses. Though as we get more science, we expand the number of ecosystems that we talk about. But it's blue carbon is really the ability of these ecosystems to suck carbon dioxide out of the atmosphere and store it at really high densities for a really long time, thousands of years.
Mm-hmm.
And they do that by trapping a lot of the carbon in their waterlogged soils because these are coastal ecosystems. They're flooded frequently by the tide. And when you have a waterlogged soil, you don't get the breakdown of carbon from the leaves and the branches and roots and all that kind of stuff. And in a regular rainforest, that gets broken down by microbes, and that carbon in those leaves goes back to the atmosphere. And that doesn't happen in these waterlogged soils.
Oh.
So you get this accumulation of organic carbon over thousands of years at really, really high densities, like maybe 3 to 5 times more carbon per hectare in a mangrove, for example, than there is in a tropical rainforest. So blue carbon refers to the kind of the carbon processes in these ecosystems, but it's also a policy term as well. And so it's about how we can manage these coastal ecosystems to conserve the carbon that's locked in already and don't release it into the atmosphere, or how we can restore them and draw down even more carbon. So it's kind of a mixed science and a policy.
Mhm. Wow, so they play like a really big role because they can store up like more carbon than usual. Um, yeah, could you talk more about like blue carbon and maybe even like mangrove forests and how they can regulate our climate? Yeah.
Yeah. Yeah, so this ability to suck up carbon dioxide from the atmosphere is a really important way of trying to take carbon emissions out of the atmosphere to then reduce the impacts of climate change. So it's really a really important climate change mitigation tool. Because you have high density, you don't have a lot of these coastal ecosystems around the world, but you have a lot of high density of the carbon in them. So you get a lot of kind of bang for your buck. So if you want, particularly for small island states and tropical coastal countries, if you don't have a lot of ways that you can mitigate or offset climate change, then using this kind of superpower of blue carbon ecosystems as a way of reducing carbon dioxide in the atmosphere has got a lot of attention from governments and companies around the world.
Wow, that sounds awesome. Um, so the Mangrove Lab, as I mentioned, you guys work a lot hands-on research. So over like these past few years, what has been your favorite project or like favorite moment? Like what emotions do you feel like when you're out in the field and like collecting data and stuff?
That's a great question. And it's hard because every project we've had has been awesome and really fun in different ways. We do a lot of things from global modeling and mapping all the way down to getting covered in mud in the field.
Hmm.
And we do that in all different places in the world. And one of the best things about this job is that mangroves are in really awesome places. So we work a lot in Southeast Asia, but also in Madagascar and in the Pacific
Wow.
and in the Americas now. And we get to, and all of these mangroves are completely different. So every project is my favorite for different reasons.
Mm-hmm.
But if I was to, if I had to narrow it down to one, it would be a and this is a really small project, right?
Mm-hmm.
Not a big one at all. But it was a mangrove restoration project that we did in Singapore. And what was really interesting about it, it was only a small project, a couple of hectares of mangrove restoration. But it actually took about 10 years. And it took 10 years because we did a lot there was a lot of stakeholder participation and co-creation of this project. So
Mm-hmm.
working with the government, working with communities on this island, to the extent that we actually set up our own community group
Oh,
called the Restore Ubin Mangroves Initiative. Ubin is the island that we were working on. And it was fantastic because we had government officials, nature nonprofits. We had local fishermen and local residents all working together. I was the only scientist in this group, right?
oh,
And
wow.
or the only formal scientist, I should
Mm-hmm.
say. And but just working with all these other people who had really great perspectives and had this passion for mangroves, which was and passion for bringing them back.
Mm-hmm.
And we were able to navigate this, and through this kind of interdisciplinary collaboration with everybody's inputs, do some really cool restoration work and using restoration techniques that hadn't been used in Singapore before. And apart from that, it was just a lot of fun. So we're
Yeah,
friends as much as collaborators on these projects now. So, scientifically, a small project, but for me, the most rewarding one that I ever worked on. It was
definitely.
really
So
cool.
you had like a many people with different backgrounds and
Yeah.
like different roles, they all came together to work on it. Sounds.
Yeah, yeah, and we all learned from each other, right? So
Hmm.
I was, and also showed me that we actually all have the same knowledge of mangroves, but just in different ways. And so being an
Hmm.
academic or a scientist isn't the best way or isn't the only way. And it's not
Hmm.
the source of knowledge, right? But people may call these plants different names, but they have as much or more knowledge than the researchers do, right?
Hmm.
We just and bringing all of those different knowledges together. I learned a lot about mangroves, and I thought I knew a lot about them. I've been working on them for a long time. And it blew my mind how much I didn't know. And learning from all of our friends and collaborators was really rewarding.
Wow, that sounds awesome. Like especially for like you said 10 years almost or
Yeah.
wow. Um, could you talk about your personal experience, like how you ended up choosing this career, and what mangroves mean to you? Yeah.
Sure. Yeah, I've always been interested in environmental science and geography, and biology and things like that as a kid. And I was always doing stuff outdoors as a kid. And I remember very vividly like a high school field trip to the coast and looking at coastal landforms and all these and wetlands and things, and I loved it.
Hmm.
And ever since then, I was like, I need to be a coastal scientist. I did not live anywhere near the coast as a kid, but I knew I wanted to. And I've lived on the coast, the whole of my career because of that. Um, so that was one motivation, from a young age, knowing that environmental science and climate and things like that were really important to me. I think another thing that really pushed me in this career was understanding the importance of ecosystems to people, and wanting to work on a topic that would have some real world impact. So particularly in mangroves, hundreds of millions of people rely on mangroves around the world. And so when we're doing research around conservation and restoration, we hope that by improving mangroves that we might be contributing to the communities that also live along those
Hmm.
landscapes. And so having some real world impact in our work was important. And I think a lot of environmental science has that. And I think that's what attracts a lot of people to want to make the
Hmm.
world a little bit better than how we found it.
Wow, very inspiring. I think that um like you said, childhood experiences are very important, can shape who you are. I think just like being in nature, I personally want to pursue like geology and environmental science, and it's just like I'm always like awestruck when I visit like mountain ranges and like that stuff. So that sounds
Yeah, the
great.
beauty of the world, right?
hmm Um, so just a few days ago, actually, Dr. Zhang and the Mangrove Lab published a new research paper about how mangroves have expanded over like the past few years, despite like declining before 2010. Could you talk about like the key points, highlights, or anything unexpected that you guys found?
Yeah. Thanks for highlighting that paper. Yeah, this paper it's been in the works for I don't know, maybe 15 years or something.
Oh
We've wanted
my,
to do
wow.
something like this. We've long had an interest in mangrove deforestation and the state of the world's mangroves and how they're doing. And we there was a big assumption, well, I don't think it was an assumption that they were really threatened.
Mm-hmm.
And people would say that mangroves are one of the most threatened ecosystems on the planet and that they would be functionally extinct by the end of this century globally and all those kind of things. And we were losing them at 3% per year and stuff like that. And and so that was also, one of the things that got me very interested in mangroves because they were highly threatened. But as we did more and more research around the world, we were kind of thinking, well, we're not kind of seeing that as much
Oh.
anymore. Not to say that mangroves weren't being lost, and
Mm-hmm.
they're still being lost today, but certainly it didn't seem as catastrophic as it did in previous decades. The problem is we couldn't really test that because we didn't have data from back, 50 or
Mm-hmm.
100 years ago, right? It was
Yeah.
very hard. But now we have about 40 years of satellite imagery, which we were able to analyze and to show that mangroves were being lost historically, but maybe not and the rates were reducing over time, but also new mangroves were offsetting loss. So that was the first surprise. It wasn't
Oh
just
wow.
loss,
Mm-hmm.
but some of that loss, at least, was being offset by new mangroves. But then the really surprising bit was around 2010, yeah, that on a global scale,
Mm-hmm.
we turned the tide on mangrove
Yay.
loss, and that we saw actually there was a net gain. Now, again, that doesn't mean that mangroves weren't being lost; they
Mm-hmm.
still were, but those losses were being offset by even more new mangroves.
Yeah.
And so that was we kind of had a sense, I think, over the last few years that certainly the picture was getting better and maybe rates of loss were reducing, but we definitely didn't expect the reversal, right? And the
Mm-hmm.
net gain. That was really eye-opening. And good news. Obviously, it covers a
Yeah.
much more complicated story, but yeah, it was. We had a sense, but to see just how much better mangroves were doing than even we thought
Mm-hmm.
was really unexpected, but really exciting.
Yeah. I feel like especially in today's like world, there's a lot of like fear surrounding climate change. It's like rare to see these optimistic stories. So it's really like unexpected, but like it's good news,
But, but
definitely.
you do bring up a good point about climate change, and whether this good news story is a permanent story or if it's a
Yeah.
temporary story,
hmm
right? So we've seen it over the last 40 years. What the next 40 years holds, it could be very
Not
different,
sure.
right?
Yeah.
Because mangroves and other coastal ecosystems are definitely on the front lines of climate change with sea level
Yes.
rise and cyclones and things like that. So a lot of work still to be done.
Yes,
Yeah, we're not off
definitely.
the hook yet.
hmm Um, yeah, as climate change is gonna uh we'll see how it ends up in 10 years, like, but hopefully it'll continue like growing and these ecosystems continue to
I hope so.
show us.
But there's a lot of people around the world working really hard to try and make
hmm
sure that happens.
hmm okay, lastly, do you have any pieces of advice or anything you want to that the audience should take away, whether you're a climate advocate or anyone interested in mangroves, any pieces of advice for them? Yeah.
Sure. My advice would be to try and find the positive in whatever you're working in, because around environmental science, around climate, around land use change, biodiversity, that it can be tough, right?
hmm
Because we face a lot of challenges, and those challenges aren't going away. But it's important that you stay inspired in your work, and it's important that you find something that you can latch onto in that work that makes you want to keep on doing it every day. And for me, I found that trying to find something positive, whether it's knowing that if we restore these, it is going to benefit somebody, or that we know conservation is working, like in this paper, and that new mangroves are happening. Whatever that positive hook is for you, I think that's really important to find that, because without that, it can be tough. Right?
Yeah.
To dedicate a career
Hmm.
build. So we want something, we want to be improving things, and we want to find those things that will help the most, right?
Yeah. Just looking for the for hope and like the optimistic aspect, and also knowing that like your team is working towards like building a better like tomorrow, honestly, like because like you said, like our future isn't promised and we have to continue working towards
Yeah,
protecting our planet.
and we got to start the work right now, right?
Hmm. Yeah.
So yeah, so
All
great.
right.
Thank you.
Thank you to Dr. Fries for joining Climate Conversations today. Thank you for your very insightful comments.
Thank you.
Thank you so
Appreciate it.
much.
Thanks.